are not accessible. If you look at the spec, the service specification explicitly says that you're supposed to return a 404 for anything inside META-INF or WEB-INF. This has actually been a source of major problems for a long time. If you actually go and grep all the class files in WAS, you'll find that it's checked a ridiculous number of times. And they still missed one. There may be other ones, unfortunately. It turns out that their file serving servlet that handles when file serving is enabled actually allows a /webinf.web.xml, so you can actually grab files outside of the WebInf directory. If you're not familiar with Java web applications, this is where all your configuration is. This is where a lot of your code actually is too, that you can then download and decompile. So this was fixed in PK 64302. A potential security exposure with the file serving feature enabled. There was no details released about this. So there may be other things that were fixed in that same fix pack. I'm not sure. I never really analyzed it, but I know it didn't work afterwards. So surely they didn't just check this in the file serving servlet. Well, yeah. So if you do a / in WebInf, you can actually get it through the JSP engine as well, which is obviously a problem. The plugin also, however, normalizes paths, so we have to play our encoding games again to get around that. But in which case, we can still go in and get the web.xml, the main configuration for your web application, by using %0, %AE, which is an overly long period, in our path, which then the plugin does not recognize, and then our %0, %80, which is overly long null byte, and suddenly we actually get the web.xml. This was fixed along with the %00.jsp issue in PK 81387, which I was surprised. I was talking to one of the IBM security architects, and he said this was the only number he can remember for fixpacks, so they worked really hard on it. Possible application source file exposure, which hopefully everybody has applied at this point. This also works for META-INF in case you want to go look at things that are left in there. So, the big question is this the whole truth? And nothing but the truth? You can actually make possible application source file actually be remote code execution in many instances. So, again, back here in WAS, instead of the plugin, we look at JSP Striking Back. If you remember, we locate a file, translate it to JSP to Java, we compile it, and then we run it as a servlet. So, if we can get a file into the WAR, we can get remote code execution through this method. So, I was looking at a web application, and I had an interesting discovery playing this game with WebInf. Here's a listing of the directory of WebInf, and there's this attachments directory. Does anybody know what that attachments directory is? I'm just curious. So what it turns out to be is that Apache Axis 1 implements SOAP with attachments. This is not Axis 2. We're talking about Axis 1, which is a little older. Okay. For those of you not familiar with SOAP with attachments, it is implemented very similar to how email is. It uses MIME headers and actually goes through and attaches things as MIME entries, MIME bodies to the main request, so that you have a SOAP, your SOAP envelope with all of its goodies, and then you have your attachments that are referenced from your SOAP service. Okay. When large files actually go through Access, it caches them to disk so that you're not, running your application server out of memory in the process of handling a SOAP attachment, anything over 32 kilobytes, and by default, these get put into the WebInf attachments directory. So, this directory is created if not present at startup, and guess what WAS's JAX RPC implementation is based on? But not their JAX WS implementation, which is of course based on Access 2 instead. So, Apache Axis actually has some interesting bugs that make this less true than you would think. It's very good at optimizing how it reads in attachments from the network. So if your service actually doesn't handle attachments, it doesn't even bother reading them. So it doesn't get to the point where it actually caches on the disk. It's just rather frustrating because we'd have to find a SOAP service that handles attachments. And at least in where I work, we don't have very many of those, if any. So it's a lot rarer to have this, which makes our attack a little harder. So it occurred to me, well, what happens if we just, you have a series of MIME attachments, instead of putting the SOAP body first, like everybody does, what if we put our attachment before the SOAP body, and, so that our attachment has to be read before it reads the actual SOAP message? Well, it turns out that actually works, but there's this other little bug in Access, the way it handles third local variables, that if you do that, it actually saves it to another file system directory, specifically where your temp directory is for Java IO, which is usually /temp on Unix machines. So, great, we can DOS 2 file systems instead of 1 with Axis, but that doesn't really help us very much. So, let's talk about SOAP encoding. SOAP encoding actually allows you to reference attachments. We just need to reference that attachment and it'll read them in. It allows this href attribute to be applied to parameters and such inside our SOAP message. So when used with Apache Axis 1, it'll actually parse the attachments and cache the large ones to our disk where we want them inside our WebInf directory. So this, of course, requires that we have a web service that's actually using SOAP encoding. So we're talking here about RPC encoded messages as opposed to document literal or RPC literal, which are different methods of using SOAP. I swear this is not my fault. Axis 1 provides an interesting feature, which unfortunately is not present in the WAS implementation, the WAS extension of Apache Axis 1. So we can't use it directly with WAS. And what happens is that the client, for whatever strange reason, can actually send a fault to the server as its initial request. Usually this isn't something that should be happening, so not surprisingly the server says, what? Send me faults. I'm supposed to send you faults, not vice versa. So, but the nice thing is that it parses it anyway first. And just for fun, SOAP faults use encoding, SOAP encoding. So we can send attachments with them too. So not only are we sending a fault, we're sending a fault with an attachment. And it also doesn't require any web services to be actually configured in Axis 1. It just requires the exposure to the Axis 1 servlet itself, which is plenty enough to actually get this to work. So let's talk about actually how to use this. We have to put together a lot of things here to make this actually work. First, the attachment file names are fairly random. And the first thing we have to do to actually exploit this is we have to connect to WAS, use the JSP bug to figure out what's currently in the attachments directory. Baseline that, then we send up our attachment as a SOAP fault. Then we get a directory listing after that, and we go through and find the JSP that we put in there, the file we put in there, and we request it as a JSP. At which point, the file is translated to Java, filed, and run. Which means we've achieved remote co-execution on WAS with all of it. So, to demonstrate this, we have a little cute SOAP shell over JSP, which baselines the attachment directly, uploads the JSP with the SOAP fault, finds new attachments, and then checks that it actually has this attachment in case the service is already handling attachments, in which case you have to find your own. There is a race condition here on some servers, depending on how they're configured and how the timeout is, especially in WAS instances deployed for development instead of production. So in our case, we need to copy our JSP quickly out of that directory so it doesn't get removed while we're using it, which is kind of frustrating. And then it proxies standard input and standard output from command line to over HTTP to the server. So if you're going to use this, and finally when it's done, it removes itself. This is exceptionally noisy in the logs, so it's not exactly very useful for anything but a demo, but it's great for demos. So let's do this. Here I have a WAS 7.0 instance, 7.0 fixpack 1, which is the last fixpack that was vulnerable. Inside of this, I have the demo application, which is going to be on the website this afternoon, that is running. And it actually is being accessed through the plugin, which gives us our plugin page. And the access servlet is actually mapped to just /access1. At this point, we have a shell script that is running our Java exploit that takes the context root directory and then the relative path to the Axis 1 servlet and gives the command name that we want to execute. And with this case, we want to execute the shell. So in this case, we see it updating and baselining it, and then we're hitting it very quickly in this case because this instance is running in development mode, and therefore it removes our attachment very quickly. It then finds it, baselines it, and it gives the shell of the server on the server. So, and we have full access to the server that's running WAS. This tends to make WAS admins really unhappy incidentally when they start executing commands. It's actually much more efficient if you actually want to exploit WAS to actually, run stuff in your JSP and have stuff natively stored inside of WAS instead of creating a shell, because most admins get a little fishy when they see a PS list that includes a shell being launched from WASP, because it really shouldn't happen. So afterwards, we just remove the JSP and we're done. So we clean up after ourselves and hopefully nobody noticed. But with that exploit, it's very noisy, so people will notice, hopefully. Not that you couldn't do it a different way. So let's talk about fixes. This has been fixed. First, we have the affected platforms. WAS runs on an unbelievable number of platforms. I counted 15, and I'm pretty sure I'm wrong. I'm pretty sure it's more than that when you consider everything. AX and Linux were the ones I dealt with explicitly, because that's what we run. Case-insensitive file systems actually are interesting because they're not vulnerable to the %00.jsp bug. And this actually, I believe, has to do with an earlier fix for security problems with case-insensitive file systems. The only one I know of is, of course, Windows that WAS runs on. So if you're running Windows, you don't have to worry about this one. Well, you still have to worry about the encoding issue, but not. The overly long UTF-8 encoding obviously depends on the JVM that's in use on the application server. In non-IBM JVMs, hopefully this will be fixed before the IBM one at this point. Those two that I know of are going to be HPUX, which runs on an HP VM, a JVM, and Solaris, which runs the Sun one, obviously. In terms of versions, 6.0 was fixed in 6.0.3.5, which is the same as 6.0.2.3, which is fixback 35. 6.1 was in fixback 23. 7.0 fixback 3, and other versions you can apply the iFix. There was also fixbacks for 5.1 and 5.2, but I don't have access to those to try them. So hopefully you have this done. Now let's talk about IBM for a second. 15 platform variants that I count. I'm on the low side, I'm pretty sure, because I didn't count things like IA64 for Windows and such. 4 maintained versions, about 60 different variants. Can you guess how long it took them to fix this? Ballpark? 8 months? It's pretty. How about 2 weeks? I'm impressed. How do you do 60 different variants in 2 weeks and have a public fix them from the time I tell them? I was very, very surprised. If you are dealing with IBM for security vulnerabilities, I would recommend that when possible, that you always submit them as a PMR, that is a service request, because that is how they handle everything related to their software. And if you don't do it that way, you're kind of in the la-la land where they're not sure what they're doing, and you may get forgotten about. But if you do as a PMR, they will get it done, and sometimes they can do absolutely amazing things, like 2 weeks to fix this sort of thing. They also ticked off a lot of people too, as we'll talk about in a second. Their fix is actually very elegant. This is, my pseudocode for it. Basically, they look at the file they're trying to open, and they ask the operating system to canonicalize it, and they compare the two, and they say, is this really the file I'm opening? And if they don't match it, well, throws a 404, which is nice. This actually has problems with it. It caused a lot of problems with people who are running on Unix systems that, for whatever reason, were putting symbolic links in their exploded wires, because that will fail. That test right there, because the canonicalization of a file path in Unix will actually return the absolute path, not the symbolic link. So that was a problem. There's some fixes for that. I haven't looked at it specifically. The WEB-INF fix is not quite as elegant. They just check to make sure you don't have WEB-INF anywhere in the URL path, which solves this problem. It does work very well. My guess is, though I haven't tried it, if you try to have a subdirectory that's called WEB-INF, it won't work, but hopefully that shouldn't happen too frequently. So before we talk about workarounds, we're going to talk about some workarounds that you can do. But first, you're more than a year behind on patches at this point if you're working in workarounds. It's a really good thing you're not running other servers. So the best workaround that I like the best is actually to disable the runtime compilation and reloading of JSPs. This is a little frustrating. The Information Center will actually tell you can disable it at the application level. This is done with putting some specific features into the IBM web.ec.xmi. There used to be a way to do this at the container level. It's still in the Information Center, and I can't get it to work. So I don't believe that it's supported anymore. This makes the fix a little harder because you're dealing with it at an application by application level instead of actually doing it on your entire server or your cell. Of course, once you disable runtime compilation JSPs, you're going to want to make sure that you pre-compile your JSPs, either deployment time or batch compile them before you go in there. Doing that works great. The other way to do this is to block JSPs, which we have to talk about a little bit. Of course, if you actually need direct access to JSPs, this is not going to work. It's going to break your application.